So last section we're going to take a look at this week is 9.4 part 3. And this is on hyperbolas. So hyperbola is very similar to ellipses, and that's why I think it can be a little confusing. But if you try to just keep track of it on a reference sheet, I think that should be enough. So first thing we'll start out with is the definition. And let's just remember what the definition was from yesterday. So for an ellipse, it was a collection of points such that if you measure the distance to two fixed points, it comes out, and you add them up, it comes out to a constant. So you measure the distance to a focus, measure the distance to the other focus, add them together, and it was a constant. Well, today, if you measure the distance from a point on the parabola to a focus, and you measure the point to the other focus, it's not the sum of them that comes out to a constant, it's the difference of them. Okay, so if you measure the distance from any point on the hyperbola to a focus, to the other focus, and subtract, that distance will always be a constant. And I'll show you a picture and I'll move the point around and you'll be able to see it as a constant. Okay, so here's a hyperbola. The hyperbola is the only conic section that's in two separate pieces. I'll tell you what the pieces are called in a little bit. Point E is a point on the hyperbola. And what I'm going to do is measure the distance from E to C and E to B as I drag point E around. So you're going to see these two numbers change. But the difference between the two of them will always come out to 5.66. I don't think I can do it. I just can't do it. Take this point, drag it around. You take 9.13 and subtract 3.47, whatever it was, it will always come out to that 5.66. If I put it over on this page. Save that. Subtract 12.67 and 7.01, and you get 5.66. So the difference is always a constant. Questions on that? Yep.
Who came up with this stuff?
With what, hyperbolas?
Yeah, like you just draw two lines and then they're always the same distance.
I don't know what the origin of it is. I know if you look at our book, I think there is something to do with a, like they talk about a sonic boom when a plane breaks the sound barrier. And they think they show a picture of the sound wave hitting the ground as a hyperbola. I think. I know, it's interesting how they figured that out, but I'd have to check that out in our text and double check it, but I'm pretty sure it's in there. Yeah. Again, how they figured it out, I don't know. All right, but that's their hyperbola. So those two fixed points that we were measuring the distance from, I called them C and B. C and B are what we call the foci. So the foci basically are inside the hyperbola. The hyperbola wraps around each focus, just like it did with a parabola. It's kind of the same idea. Now, what did we call the line yesterday that went through the foci?
Major axis.
The major axis. Well, with a hyperbola, they call it the transverse axis. And the way you can remember the difference between the two, because we're going to have a name for the minor axis, but it's not called that. with a hyperbola is think about a hyperbola, and if you want to go from one side to the other, you would have to traverse it. Right? Traverse means to go across. So when I think of traversing, it kind of sounds like transverse. So transverse is the axis that goes across the hyperbola, connects one branch to the other branch. Now, if we took a hyperbola, and these are the foci, and we draw a line segment, and we find the midpoint of that line segment, what do you think this point is called? Yep, that's the center. So it's the midpoint of the line segment that connects the foci. And the two branches of the hyperbola always bend away from the center. Now, what did we call the axis yesterday that went through the center and it was perpendicular to the major? The what?
Minor axis.
The minor axis. Well, in a hyperbola, it's called the conjugate axis. Now, I'm not sure of the origin of that name, conjugate. I know we talk about conjugates when we do other things, but I'm not sure that that word has any connection with conjugates like that we've studied before. All right, so we got the transverse axis and the conjugate axis perpendicular to it. So I've been using the word branches. That's what you call each piece of a hyperbola, the branches. In a problem like this, we would say we have a left branch and a right branch. That's one case. Or you can have a top branch and a bottom branch. Those are the only two cases we're going to look at. Like an ellipse. Two cases. All right. If I draw in the transverse axis, there is a name for this point and that point. Anyone think they know? Yep, those are the vertices. Now, these are the vertices. V1, V2. And remember, the foci are here. The foci are outside of the vertices. The vertices are inside. Now, think of an ellipse. Here are your vertices. Where are the foci? Inside. So, big difference here. With a hyperbola, the foci are on the outside. With an ellipse, the vertices are on the outside. So it makes these two conic sections extremely similar in terms of the formula and everything we're going to do. Now, when we're drawing the branches, we're going to need something to kind of help us, and we're usually not going to find coordinates. Let me give you a hint. What do you think is going to end up happening? We're going to have asymptotes, right? We're going to get two asymptotes. I'm going to tell you what the formula is to find them. They're going to have a slope and a y-intercept. But the idea is when you sketch asymptotes, it's going to give you an x shape. And then your hyperbola is either going to be in the left or the right part of the x, or the top or the bottom part. All right, so we got to practice a little bit with how we write the equation. It's going to be like y equals mx plus b. Unless it's not at the origin, then we're going to shift it. Then point slope would be the easiest way to do it, because we're going to have it go through a certain point. And the asymptotes always go through the center. Always. If it's at the origin, then the equation is a little simpler. If you shift it, then the equation for the asymptotes gets a little more complex. All right, so we're going to look at the case, first of all, at the origin, and then towards the end, we'll shift it. Remember, this time, the transverse axis is the axis that goes through all the important points. So your foci are going to be C units away from the center. It's just like it was yesterday. C is going to be the distance between the center and the focus. A is going to be the distance between the center and the vertex. It's exactly the same as yesterday. And this will be the case where the transverse axis is horizontal. That means your branches would open left and right. So the transverse axis would go like that. So put up the equation, and I want you to tell me what looks different about it compared to an ellipse. It's a minus, right? Yesterday, you had a plus right there. Today, it's a minus.
The other equation is a plus instead of minus.
Right. The other equation, yesterday it was c squared equals a squared minus b squared. Today it's a squared plus b squared. Now, what I want to do is compare this to the other one we're going to look at, and I want you to tell me what switched. What switched yesterday when we go from a horizontal to like a vertical major axis? The A and the B switched places. Okay. Let's look at the other version, and I'll give you, make sure you copy that down. And I want to compare this to the next one. The X and the Y switch places. It's a little different. The A and the B can never switch places today. The A is always the first denominator, and the B squared is always the second. So then how do we tell which way the major axis goes? Yesterday we could tell by where you put A and the B, if A was under the bigger number. Today, what you're going to look at is which variable is the positive one. Here, the Y is positive, and the X is negative. Whichever variable has the positive is the direction that the transverse axis goes. The Y is positive, so it goes vertical. If we go back to this one, the X is positive, which means it's going to go horizontal, because the X is horizontal. Okay, so the way you tell the direction of the transverse axis is by the letter that is positive, X or Y. And you always put the positive one first, and the negative one second. Other than that, everything is pretty much exactly the same. The only thing that is extra with these are the asymptotes. This particular parabola has asymptotes that y equals plus or minus b over ax. When the transverse axis is horizontal, yes. And there is no y-intercept on this because it's going to go right through the center. And the center is at the origin, for now. All right, so you do need to find b, and you have to find a. They're going to be all used as your slope. Now, b yesterday was the distance from the center to the minor axis. Visually, today, b doesn't really have a connection visually that I know of. I know it's the rise and the slope, but that's all I know. Okay, a is the distance from center to vertex, c is center to focus, and b is the rise in the slope. Questions on that? Okay, so when we're graphing a parabola, I think we're just going to go with the asymptotes. We're not actually going to find other points. We're not going to do that. So again, A is the distance from the center to the vertex. C is the distance from the center to the focus. Now, I didn't write down today that A is always bigger than B. That might not be true. For an ellipse, it's true, but not necessarily for a hyperbola. And I just put absolute value because remember, it is a distance, so you should never think of distance as a negative number. I don't think, I'd have to double check. I'm not sure A can even come out as a negative number, but if it did, you'd never think of it as a negative because it's distance. All right, so let's find the equation of this hyperbola, and we're going to graph it. Okay, so center, 0, 0. Focus is 3, 0. Vertex is negative 2, 0. Before we do a nice sketch, let's just figure out which way the transverse axis is going to go, and that'll tell us which equation we use, because I showed you two. There's your center. Your focus is 3 units to the right. And you have a vertex 2 units left. Where do I have another focus?
3 units left.
3 units left. Yeah, so here's a focus right here. And where do I have another vertex?
2 units right.
2 units right. So the transverse axis goes through all those points, which means the transverse axis is going to go in which direction? Horizontal, which is which letter? X. So we want the x to be the positive. So we're going to start out with a fraction minus another fraction equals, what number does it always equal? 1. What letter, what goes in the first denominator always?
A squared.
A squared. Second denominator?
B squared.
Okay, so every problem starts like that. Now you choose where to put the x squared and the y squared. We want it to go horizontal. So we're going to put the x squared there and the y squared there. So that's your equation. Questions on the equation? Okay. So now A is the distance between the center and the vertex. What's A? 2. B we're not going to be able to get without a formula, but C we can. C is the distance from the center to the focus. 3. And what's the formula that connects A, B, and C? B squared plus B squared. So fill that in and solve for B. So C squared is 9. A squared is 4. So in this case, B squared equals how much? You don't need B unless you plan on writing the slope. Okay, we are going to write the slope, so I'm going to put B over here, but B squared is what we need.
How did you find C?
The distance from the center to the focus. Okay, let's write the equation. All right, somebody tell me what's my equation?
X squared over 4 minus y squared over 5 equals 1.
4 minus y squared over 5 equals 1. Perfect. There's your equation. Now, to sketch it, we need the asymptotes. What is the slope of my asymptotes? Like, what are the letters?
B and A.
And which one's on top? Which one's the rise? B. So it's HBA. When your transverse axis is horizontal, the slope is B over A. I haven't shown you this one yet, but when the transverse axis is vertical, the slope is A over B. VAB. So if you can remember VAB, vertical is A over B, horizontal is B over A. Okay, we'll get to this in a minute. Okay, so asymptotes. We're doing this. Transverse axis is horizontal. What's my B value? Square root of 5. And my A value? 2. Now, because I'm going to graph, I do want to know roughly what the square root of 5 is, because that's my rise. All right, so square root of 5. Bless
God
you.
bless you, Mabel.
Thank you.
5 square root of 2.2. That's as close as you're going to get graphing. So not the nicest rise and run, but so when you sketch it, you're going to start at the origin. You're going to go up 2.2, that's your rise, over 2. Up 2.2, now you're at 4.4, and over 2. And then same thing here. You're going to go down 2.2 and right 2. So go down 2.2, right 2, down 2.2 again. Now you're at negative 4.4, and then right 2. And draw your lines. And are the branches going to be left and right or top and bottom?
Left, right.
Left and right. So here's the center. And we want to draw the branches getting very, very close to the asymptotes. If you draw your asymptotes, you don't really need more points. So let's see, was the center 0, 0? Yeah, so center is 0, 0. Vertex is negative 2, 0. I do want to put that in. And 2, 0. So these two black dots on the left and right of center, those are my vertices that I'm going to draw it right through. So stay very close to it. Come away and get close again. Same thing over here. Stay pretty close. Start to curve away. And get close again. And that's your sketch.
What about the focus?
What's that?
What about the focus?
The focus, you don't have to plot them to graph it. The focus would be at 3, 0 and negative 3, 0. That's an imaginary point that it wraps around. Remember, the hyperbola does not go through the center. The center is a point that's in between the branches that it never touches. The branches don't touch. Okay, they're always separate. Okay, questions on that sketch? All right, let's try this one. Is that set up in the standard format to discuss it?
Yes.
Yep, it's fine. All right, so let's identify what we can. What's A in this case?
4.
Because it's right here?
No.
No. But that's 4.
Square root of 16.
It's the square root of 16. A is always the square root of the first number. B is always the square root of the second. Now, why do we even need C? If we're going to discuss this, part of describing it is putting the foci. So we need C. C squared equals, what goes on the other side? A squared plus B squared. So what is C? Which is?
2 square root 5.
2 square root 5. Okay. So here's all the things you want to describe. There is one extra thing this time, because we're doing a hyperbola. You also have to tell me the asymptotes. Okay, but the first 4 things are the same. Let's start with the center. Where is the center?
Origin.
0, 0. How do you think you'll know when it's not the center?
HOK.
You're going to have an x minus or a y minus. Yep, that's how you'll know. Okay, so the center is 0, 0. The transverse axis, which way does it go? Left to right, why?
Bigger numbers and the X is the big number. X is first.
The x is first.
Yeah.
Whether the 16 was over on here or the 16 was over here, it would not change the direction of the transverse axis. The fact that the x is positive tells you that it's horizontal. So transverse axis is horizontal. How far away are the vertices from the center? 4 units. 4 units which way? What's 4 units left of center? And 4 units right? Okay. How far away are the foci from the center? So we're going to have plus or minus 2 root 5, 0 for the foci. Asymptotes. What's the formula for the slope? What letter over what letter when it's horizontal? HBA. So HBA, B over A, right in that order. B is 2. And what's A? 4. So Y equals plus or minus 1/2 x. Okay. So there's vertices, foci, center, transverse axis, and asymptotes. Questions on describing a hyperbola? Okay, another discuss. Is this one set up to discuss? No. What's wrong with it? It's not equal to 1. So how are we going to make it equal to 1? Okay, so we're going to have x squared over 4 minus y squared over 1. Okay, what's A? 2. B? 3. We don't have an H or a K. And then C is going to be 9. Remember, you're adding now.
Oh, no.
So C squared is A squared plus B squared, which is the square root of 13. Questions on how we got A, B, or C? Okay. What's my center?
0, 0.
0, 0. Do that first. Transverse axis goes which way? The x is positive, so horizontal. How far away are the vertices from the center? 2 units which way? Left and right. So positive or negative 2, 0. How far away are the foci? So what would be your coordinates there?
Plus or minus 13. Square, yeah.
And asymptotes. What's the slope of the asymptotes going to be?
3 over 2.
Plus or minus 3 over 2. So if we had to graph it, that'd be a much easier one because now you don't have any decimals. Okay. Questions on how we got any of those? Okay, so the other piece. So now, instead of everything lining up horizontally, it's going to line up vertically. That means the y is going to come first, and that will be your positive. The x is going to come second, and that will be your negative. A squared is still the first denominator. B squared is still the second. 1 is still on the other side. And the formula for A, B, and C is still the same. Notice now, all these numbers are the same. And they always will be the same when the transverse axis is vertical. They might not always be zeros if you shift it, but they'll always be the same. So this will have asymptotes as well, but the slope is a little different. Does everyone have up to the foci? Okay. Well, that doesn't really help. So this time, the slope is going to be vertical is A over B. So if you remember that, vertical A over B. Plus or minus. So when the transverse axis is vertical, the slope is A over B. No need to worry about a y-intercept because it's still at the origin, so it would just be like a plus 0. We are going to do one of the last examples where it's not at the origin. And then you'll have an h and a k. And the hk is the point that the asymptotes go through. It always goes through the center. Let's discuss this one. What do we have to do to get this one ready to discuss? Yep. Divide everything by 4. So we're going to get y squared over 4 minus x squared. What's going to go in the bottom? 1. Equals 1. What's A? B? C? 4 plus 1, and take the square root. And now we just have to write down our answers. Okay, center.
0, 0.
Yep, you'll know because this numerator is going to look a little more complicated when it's not 0, 0. Transverse axis goes which way?
Vertical.
Vertical, because the 4 is because the bigger number is under it.
No, because the y is first.
Because the y is positive. It doesn't matter where the bigger number is. It has nothing to do with anything today. The y is first, so it's the positive. So it's vertical. How far away are my vertices? 2 units. Which way? Up and down from the center. What's 2 units up from center?
0, 2.
What's 2 units down from center?
0, -2.
Okay. How far away are the foci?
4, 5.
And the coordinates of them? Yep. Up and down square root of 5 units from the center. You can use the plus or the minus when it's at the center or when the center is at the origin because it's going to be symmetric. When you shift it, these numbers aren't necessarily the same. Asymptotes. What's the formula for the slope this time?
A over B.
Vertical is A over B. That. So my slope is going to be 2. And plus or minus. Okay. Questions on that? Okay, let's see, get this one, and then we're going to shift. Okay, find the equation. They gave me the vertex, they gave me the center, they gave me the foci. It just seems like a regular problem, pretty much. Find the equation. Okay. What should we figure out first here?
Which way the transverse axis is.
Yeah, because that's going to be our basis for what formula we use. Okay, so do a quick sketch, or if you can visualize it in your head, that's fine. There's your center. Vertex is 0, 2. And where else? 0, -2. Foci, 0, 3. 0, -3. Doesn't really matter which one you label 1 and 2. I just put the 1s on the top and the 2s at the bottom. Yeah, that's fine. So which way does the transverse axis go? Vertical. Yep. So let's set it up. We know all that. What letter is going to come first? Y squared minus x squared. Okay. Now, let's write these up. What's A?
4.
2. B we don't know, but C we do. 3. And now 9 equals 4
Square root of 5.
plus b squared. It's going to be the square root of 5. But b squared is what we really need unless you're writing the asymptote. Then you need b for part of the slope. Okay. In this case, b would be the run. It would be in the bottom. Okay, so equation. Y squared over 4. X squared over 5 equals 1. Okay, and usually I show you at least one on the calculator in case you have to sketch on that. This is a good one because the y is positive, so I don't have to mess with that. If I wanted to sketch this, what letter has to be by itself? 1. What could I move first to the other side? X squared over 5. And how would you move that? Just add it. So let's do 1 plus 1/5 x squared. Okay, what would we do next? Multiply by 4.
Take square root of.
So that's a distributive property, 4 plus 4/5. And then the last step?
Square root.
Square root. So I'm just going to go like this. And how many answers do you get when you do square root?
Plus or minus.
Plus or minus. So there's the equation of a hyperbola. Not how I think of it. I think of it like what's in the box. But if you had to graph. All right, let me get my calculator. Now, does a hyperbola pass the vertical line test?
Yes.
No. No matter how you draw it, it's never going to pass the vertical line test, which is why you cannot sketch it in one piece. So you're going to sketch each branch. So we've got the square root of 4 plus 0.8x squared. It's just easier for me to type it in as a decimal. And the negative of that. Right, let's do zoom 6. And we should get 2 branches. Okay, there's your first branch. And your second branch. So there's a sketch of the hyperbola. Looks like the vertices are 2 units up, 2 units down. We can confirm that. Yep, looks good. Questions on that? Okay, I don't think we need to do this one. It's more of the same type. So, let's look at the last thing. We can shift the parabola, and we can have the center at HK. And the book gives you this whole chart of how you can fill it all out. I don't think you need any of that chart. It just complicates it. It's like a lot of stuff to try to memorize. I mean, there's a lot. So, all you have to know is this. If you shift it, x gets replaced with x minus h, and y gets replaced with y minus k. Now, you might look and say, wait, they write the formula different than you do. That's still c squared equals a squared plus b squared. They just have it rearranged. I have it arranged for c squared, they arranged it for b squared. Now, this substitution that you have to do, not only happens in the numerators, it also happens in the equation of your asymptote. And what that basically does is it turns the equation of your asymptote into basically point slope. This is like y minus a y1 equals your slope times x minus x1. This is now point slope. That's what it is. But when you are horizontal, your slope is still b over a. And when you're vertical, your slope is still a over b. The slope stays the same. Just make these two substitutions everywhere. And I show you a picture of what it could look like. And your transverse axis is horizontal or vertical. Any questions on this idea? Yeah?
When we subtract, are we going like positive or like?
So the h is always going to be the number after the minus sign, and the k is the number after the minus sign as well.
Yeah, but like say the h, like it's x minus h on vertical, are we going up or down?
Oh, which way is it shifting it? So when you look at h, if h is a positive number, it would move it up. And if k is a negative number, it would move it down. But if k is negative, then it would actually become like minus a minus, and it would become plus. All right, let's try this one. So find the equation of the hyperbola. So how many letters do we have to find? 5. HK, ABC. So we have to find 5 letters. 4 out of 5 are going to be pretty quick. What's H? 1. What's K? Negative 2. A is center to vertex. 2. C, center to focus. 3. And B, well, c squared equals a squared. We've had this number come up a lot today. B is the square root of 5. Again, not important unless we are writing the asymptotes. And we're not. We're writing the equation. So we didn't technically say to write the asymptotes. I can if you want to see it.
How is A2?
We probably should write the asymptotes because this is different than the other ones. A is 2, center to vertex, 2 units apart.
Alright.
Because the y values are the same. So just look at the difference between the x's. Okay, questions on those 5? Okay, let's write our equation. It's going to equal 1. What's going to be in the first denominator?
A squared,
Second denominator?
U squared.
E squared. Now, visualize these points. Your center is right 1, down 2. Your focus is right 4, down 2. Your vertex is right 3, down 2.
So it'd be horizontal.
The transverse axis is horizontal, which means which letter comes first? X. Which letter comes second?
Y.
Y. And if this was at the origin, that's all you need, x squared, y squared. But we're replacing x with y.
X minus H.
And replace y with,
Y minus K.
and there's your formula. Now fill it all in. All right, so it's going to be x minus 1 squared over minus y plus 2 squared over 5 equals 1. And let's write the asymptotes. So let's start with how we would normally do it. Y equals, what's the slope when the transverse axis is horizontal? B over A. So plus or minus b over a. And that's all you would need if it was at the origin. But we replaced x with x minus h and y with y minus k. So now fill in your h and k again, and your a and your b, and you'll get your equation. Okay, this is point slope. So it's y plus 2 equals root 5 over 2. Yep. And then x minus 1. There's the equation of your asymptote in point slope form.
What do we want to subtract 2 from both sides?
If you wanted to get it in y equals mx plus b form, you could distribute that out. Hopefully that number would actually be nicer. But you could distribute that and then subtract 2, yes. I won't do it on this one because that's not a good example to do it with. Question on that? All right, so let me, since this is going to be the last video, let me just put up the test topics. So there'll be 3 conic sections: parabolas, ellipses, and hyperbolas. For each type, you should know all the basic problems that you can have. You should know how to take information and translate that into an equation. You should know how to take an equation and translate that into all the information that's important. It's different for each conic. So like, for an ellipse, I'm looking for the major axis for information, vertices, foci, center. For hyperbolas, I'm looking for transverse axis, vertices, foci, center, asymptotes. Okay, so you can get all that information from the equation. And then you should be familiar with the graphs. How to either graph something, or if I give you a graph, you can tell me the equation. You should be able to look at it and find the A, the B, and the C from the picture. So we'll have 3 of these, 3 of those, 3 of those. Questions on that?
Review day tomorrow?
And tomorrow for you guys is a review day. There is an assembly period 7, I think, about course electives, but it won't affect you guys, so you don't have to worry about that. Periods, I don't know, I think it's course electives, I'm not sure. But it's periods.
Or have to play catch up? Unless you just not.
Okay, so there's the homework for tonight.
I mean, she might not be there today either.
Okay, we'll go over that homework tomorrow. Is anybody on a field trip Thursday, ROTC? So if you want to take the test tomorrow, you can. Otherwise, if you want to wait, especially if you were absent, you might want to wait. But keep in mind that there is a vacation week in there, so you're not going to be able to take the test for a couple weeks.